Hello, in this video I will be covering your notes on graphing exponential functions. So the exponential function, recall, is f of x equals a times your b value to the x power. The parent function that we're going to be using to make all of our comparisons is y equals 2 to the x. Sorry, I'm trying to get the lighting to show up well. All right. So the first thing I want you to do is look up here and recognize that we've got y equals a times b to the x minus h plus k. And you might go, well, what in the world is that? Well, notice it's really just the exponential function where we have this h and k going on. So you might recall that when in Math 2 you studied quadratic functions, you did vertex form, also known as transformation form, which looked like y equals a times the quantity x minus h squared plus k. We've also studied in this course the absolute value function, y equals a times the absolute value of the quantity x minus h plus k. And we talked about how we can identify hk by remembering to switch keep. So when you switch keep these two values, your h and your k, it's going to result in an xy, which will move your x values either to the left or right, and it will move your y values either up or down. So that's really what we're going to be applying here. So I hope you write all this and pause it if you need to. So again, here I've got that the a, h, and k values do the same things that they did for the absolute value function. Remember the a value caused it to either get skinnier or get wider. And the h value again causes it to go left or right. And the k value causes it to go up or down. So what we're going to do is first look at comparing f of x equals 2 to the x to the graph of 2 to the x minus 1, and then add 4. So again, remember the first thing I told you to do is to switch keep when identifying your hk. So whatever you see here, if it is minus 1, switch it to the opposite, which would be positive 1. And then this is your k value, which we keep as positive 4. So again, switch, keep. That's what we mean by switch, keep. Switch the sign of this number here beside the x, and then keep this number here on the outside. Well, then think, well, how would I move on the x-axis 1 and on the y-axis 4? So I want you to think, just if you were at the origin, how would I get to the point 1, 4? We would go right 1 and then up 4, right? So if that was 4 and that was 1, we would go right 1, up 4. So those are the transformations you're going to write, that you would go, that adding these two features onto the equation of 2 to the x makes the graph move right 1 and up 4. So you're going to put little bullet points to list those two things. And that's it. We're going to graph these in a minute, and you'll kind of see more so what it means. But you're going to, again, just switch keep, write this ordered pair, and then think, how would I get to the ordered pair from the origin? I would go right 1 and up 4. And those are your transformations, okay? So notice we have 2 to the x, which is growth. Over here for number 2, we have y equals, or f of x equals 1/3 to the x, which just means decay. But notice we have 3 things added. We have a negative in the front, then we have this plus 7 added onto the x, and then this minus 1. So the first thing is to recognize that a negative will do the same thing to any function. So in other words, if I have in Desmos, let me go here to my Desmos and type in y equals 1/3 to the x. If I think, well, what does a negative do to this graph? If I put a negative here in front of the parentheses, notice it creates a graph that is a reflection over the x-axis. So it just reflects over the x-axis. So you can state that that's an x-axis reflection or a vertical reflection. So again, this feature here results in an x-axis reflection. Again, meaning it flipped over the x-axis, and that will happen every time you have a negative in the front. Remember here, if you keep switching the +7 to a -7 and keeping the -1, again, think, how would I get to the point -7, -1 from the origin? Well, on the x-axis, we would go left 7 and then down 1. So that's what you write. Left 7 and down 1. And we can see how that would work here if we were to add in all those features. So if up here my exponent, if I'm doing this in Desmos, by the way, if I try to do +7, and notice that after the x, if I do +7, it actually brings it down, and I don't want that to happen. I want it to be +7 in the exponent, which means I need to enclose the exponent here with parentheses. Then when I do +7, it'll do what I expect it to do. And then -1, okay? So what this means is if I identify a point on the x-axis here, or excuse me, on my red function, like maybe this y-intercept here at 0, 1, it flips down to 0, -1, but then ultimately that point also moves left 7 and down 1. So 1, 2, 3, 4, 5, 6, 7, down 1. And then I have another point right there. Okay, so that's what it means, that this point here would reflect over my x-axis, and then it would move down 7, or excuse me, left 7, and then down 1 to this coordinate here at -7, -2. Okay, so that's what we mean by listing your transformations. So now for number 3, for 3 through 6, if you take a minute to look at these, you'll notice that all of them have y equals 2 to a power, and then k value after it, okay? So what I want you to do is we're going to sketch them, and then we're going to state the domain and range. So in order to sketch them, first and foremost, we should know what the parent function looks like. Hold on, where'd my pencil go? Pencil. Well, I'll do this one in pen and then do the other one in my orange, okay? So if I graph y equals 2 to the x power, and I think about what that looks like, I'm going to go over here now to Desmos and type in 2 to the x power, y equals 2 to the x. So y equals 2 to the x. To do the exponent, by the way, you hit Shift 6 in Desmos. So if I look at that, I can see that it hits the x-axis at 0, 1. If I go up here to my settings wheel and click on that, I can actually tell Desmos to take my y equals 2x and turn it into a table. And when I do that, I get these ordered pairs. So what I would do is, first of all, understand, and I'm only going to do this for the very first one. Let me shrink the screen down. Make it go in. So can I make it go in without being too tiny? I'm trying. There we go. All right, so if we're graphing y equals 2 to the x, and I think, well, what's a good table for that? I'm going to look over here, and this is a really good table. So in fact, I'm going to have the order pair 2, 4, 1, 2, 0, 1, -1.5, and then -2, and we only go up a quarter, so that's barely over the 0. So I'm going to put those order pairs, but I'll start with -1. -1, 0.5, 0, 1, 1, 2, and 2, 4. And notice that this graph is going down here on the left. As we move it left, it's going down and getting closer and closer and closer to 0. See how it's getting closer to 0? But it never hits 0. So we say that it has an asymptote, a horizontal asymptote, on the x-axis. So I'm going to graph this y equals 2 to the x over here. So first things first, I want you to always put a horizontal asymptote where it belongs. In this case, for y equals 2 to the x, which we would consider the parent function, meaning the graph before it is shifted with the h and k. So put that horizontal asymptote. I'm going to put HA for horizontal asymptote at, and that's the line y equals 0, because it intersects our y-axis at 0. So then I'm going to plot these points. So from the origin, I'm going to go left 1, but up a half. 0, 1, 1, 2, and 2, 4. Feel free to pause the video so you can catch up with notes, because you should have everything I write on my paper should be on your paper. And on the left, I'm going to connect it, but make sure it sits above the x-axis, and then go up here and draw an arrow. Go to the edge of your graph. Now that's what 2 to the x does. So note you've got 1, 2, 3, 4 points. So that is what y equals 2 to the x looks like. Now what I want you to do is graph this right here, but understand it from transformations. So if I consider what these two transformations are, remember this ordered pair from switch keep would be what? Switch this to a -2 and keep this -2. So that's -2, -2. How would we get there? From the origin, you would go left 2, then down 2. So come down here and write left 2, down 2. Now what that means is that every one of these ordered pairs that we just plotted for 2 to the x is going to go left 2, down 2. So I'm going to put a new point with my new color. You want to use a different color if you can. Left 2, down 2. Now I'm going to take this point at 0, 1, left 2, down 2. And this point at at -1, +1/2, and go left 2, down 2. But in addition to the horizontal asymptote, or to the all these points being shifted, the horizontal asymptote will also shift down to the line y equals -2. So then when I connect all these points, it'll look like that. So that's how you graph this right here, is you take the parent function and shift all points left 2, down 2. Now, if you have to graph all the others, could you just go in Desmos and type them in and get ordered pairs? Yes. But let me make it clear. Just like here, I stated the asymptote is at y equals 0. For this new graph, our horizontal asymptote will be at y equals wherever it hits that x-axis, which was -2. In fact, it'll always be this value right there. That will be important. On your test, you're going to be asked questions like, where is the horizontal asymptote? Well, if we look on a graph, we're not going to see a dotted horizontal asymptote. You have to understand that it serves as a boundary line. I always tell my students, I want you to think about like if you had a dog at home and you put in an invisible fence. If you put in an invisible fence, you don't see it, but it serves the purpose of the dog can get close, very close to it, but it can't touch the invisible fence because it would get shocked. So think of this as like your invisible fence line that's keeping your function from touching it, okay? So I'll do number 5 next. So we'll just take this same function we already have in here in Desmos. And again, beside it, remember we need parentheses. Oops, not like that, in front. So x minus 6, then hit your right arrow to come back down and hit +2. And we can hit settings and change it to table and get some more ordered pairs too. But notice this time we see these ordered pairs. So what you might want to do is go, oh, well, I should try to have some of these ordered pairs. Or to be honest, that this isn't my favorite function, because what happens is you have to keep adding to your table. So let me go, how did it go back to that? Oh, there we go. So you can actually go down here and keep hitting, let me see if you can just hit enter. then you can keep going till you get some nice ordered pairs that are easier to graph. So again, just put your cursor over here in the X's and keep hitting enter, and it will keep adding on, okay? But clearly these points right in here are going to be the best ones to graph. So that means on my paper, I would go, where's my asymptote? So do y'all see how these x values, or the y values are getting closer and closer to 2 as x gets more negative? So that's telling you that's where your horizontal asymptote is. Also because, what did I tell you? It's always the k value. So let's put that you have a horizontal asymptote at y equals that k value 2. So let's go to positive 2 and put a dotted line right here where the y would be negative 2. Okay, it's your horizontal asymptote. Just like your invisible fence. So now take these order pairs and graph them. So let's go to 6, 3. So from the origin, I'm going to go right 6, up 3 and put a point. I'm going to go right 7 and up 4 and put a point. And then 8, 6. So 8 and 1, 2, 3, 4, 5, 6. And 9, 10. So 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? And these are the points I would use. Just make sure when you connect, you get closer to that line, but don't go below it. Don't touch it. And then make sure you write those order pairs. So 6, 3, 7, 4, 8, 6, and 9, 10. All right. So I'm not going to take the time to do 4 and 6, so this won't be a long video, but you should practice those, and you can clearly just type them in to Desmos. One of the other things I want to make sure we go back and do is stating the domain and the range for each. So the domain of every single exponential function is going to be negative infinity to infinity, because every one of these graphs goes left forever and right forever. Now this one goes up and right, but it's still going right. So imagine it going up and right. I'm still going right. Agreed? So I'm going left forever and right forever. So for every single one of these, your domain will be negative infinity to infinity. But your range will be, remember, range is lowest y to the highest y. Your lowest y, it doesn't get to negative 2, but it gets closer and closer. So remember, it's negative 2, but you would use the left parent, not the bracket, because it never actually hits negative 2. So the lowest is negative 2 exclusive, but it does go up forever to positive infinity. So that's for this one here. For this graph here, your domain is negative infinity to infinity. Why? Because I said it's always all reals. It goes left and right forever. See, left forever, and that's going up and right forever. But my range, again, is above 2. So that k value that is going to, value there is going to come in often. So it doesn't include 2, it's above 2, but it's everything from 2 up to positive infinity. Okay? So similarly here, I know that I have a horizontal asymptote at y equals negative 2, that my domain is negative infinity to infinity, and that my range is, it's going to be, if this is my negative 2, it's going to be above the negative 2. So from negative 2 to infinity. So these are things I know just by looking at that k value. Okay? Similar here. Where's your horizontal asymptote going to be? At y equals 2. What is your domain going to be? Negative infinity to infinity, because it always is, for every single exponential function. And again, find 2 and put a horizontal asymptote. The graph is going to be above, so from positive 2 to infinity. All right. And again, you could finish the graphs by simply putting that in Desmos, the way I did over here on the right. and getting some ordered pairs to graph. So to finish this up, it says given f of x equals, and then this equation, what is the asymptote of the function? Guess what it is, guys? It's y equals -7. Now this one here says what is the y-intercept? So I'm going to go ahead and type that in. So f of x equals 1 over 2. And then I'm going to do times 4 to the, so shift 6 to hit that caret top. And then parentheses x plus 2, close parentheses, minus 10. So you should be maybe pausing, and maybe you can open up Desmos and try that, type that in. So once we have that in, you see the graph, and it's asking what is the y-intercept. So, you know, your x-axis goes left and right, your y-axis goes up and down. Simply click here, boom, on the y-axis, and your y-intercept is at 0, -2. And then lastly, for question 9, which of the following has a y-intercept at 0, 7? It's multiple choice, so you could type all of them in. 3 to the x. Oops, not typing.